Welcome to Course 3, Module 1, Impact of the Cybersecurity Landscape on Emerging Technologies. I am Bayedo. In this session, we'll explore how today's cutting-edge technologies are influencing and being influenced by the cybersecurity landscape. From cloud computing and the Internet of Things, IoT, to artificial intelligence, AI, and robotics, the opportunities are vast, but so are the risks. So let's dive in. Let's explore the cybersecurity risk of emerging technologies. Emerging technologies promise transformation, but every new feature or function that we build also presents a potential new vulnerability. Think of it like constructing a futuristic building made of glass. It's beautiful, right? And innovative, of course, but every pane is another surface that must be protected. So we look at how technologies like cloud computing, IoT, AI, and robotics introduce new risk vectors and what strategies we can use to protect them. So the key topics covered in this module are overview of emerging technologies, cloud security with their risks and strategies, DevSecOps and secure development, IoT security risks and mitigation, AI and machine learning vulnerabilities, and robotics security. Did you even know that by the year 2025, the number of IoT devices worldwide is expected to surpass 75 billion, and each one potentially opening a door to cyber threats? Now let's look at the overview of emerging technologies and their security risks. Let's begin by framing the core technologies, and then we'll focus on the risks that they introduce, each of them. We'll look at the technology, their use cases, and the cyber risks that they pose. Now, do not worry too much about some of these terms, because as we go along in this session, we will focus on each of them and explain a lot better. So we look at cloud computing, and it's used for data storage and scalable computing. And the risk it poses are misconfigured storage buckets, insecure APIs, and data breaches. And then IoT is next. It's used as smart devices at home and industrial controls. And the risks that IoT poses are weak authentication, outdated firmware, and botnets. And then artificial intelligence, and it's used for automation, threat detection, and so on. And the risks associated with that are poison models, adversarial inputs, and privacy leaks. And then we have robotics, and it's used for manufacturing and healthcare. And then the risks are tampering, lack of endpoint security, and firmware backdoors. So let's expand a little more on the risks. For cloud computing, we have cloud misconfigurations. This happens when, for example, a storage bucket is left publicly accessible on AWS. It's like renting a storage unit and forgetting to lock the door. Anyone could walk in. And with IoT, we have weak authentication. Many devices that ship today, they're shipped with default passwords like admin or 1234 or something easy like that. And that's basically leaving your front door unlocked. Who does that? And then we have the AI, which is model poisoning. If you feed manipulated data into a machine learning model, it can be trained to make the wrong decisions, similar to giving someone false directions repeatedly until they internalize the wrong path. And then under robotics, we have robotic endpoint risks. For example, in manufacturing, an unprotected robot might accept an instruction sent its way, even a malicious one that could halt production or worse, or even harm people. So let's explore the best practices to keep these technologies safe. For cloud, we use CSPM tools. We encrypt all data and even apply least privilege access. And then for IoT, we enforce strong passwords. We isolate devices on the network and ensure automatic updates. For artificial intelligence, we validate training data sources. We apply differential privacy techniques and monitor for anomalies. And for robotics, we implement firmware signing, monitor operational behavior, and restrict command interfaces. If you look at the visual aid, you'll see infographic showing attack surfaces in cloud, IoT, and AI. Please take a minute after the session to study it. A real-world example was a Capital One cloud data breach in 2019. a cyber criminal exploited a poorly secure AWS S3 bucket, exposing sensitive data of 106 million customers. This incident spotlighted the risk of inadequate cloud configurations. So lessons learned from there is that misconfigured cloud services are still one of the top cybersecurity risks. Now let's look at cloud computing on its own. We look at the security risks and the defense strategies. Cloud computing offers scalable infrastructure and services, but it also introduces a new set of risks. So let's look at the shared responsibility model. Under infrastructure security, the cloud provider is responsible for physical and data center security, while the customer is responsible for firewall rules and network configuration. In storage and compute, the cloud provider is responsible to secure services like S3 or EC2, while the customer is responsible for user permissions and encryption. And for IAM, which is Identity and Access Management, the cloud provider is responsible for IAM tools like AWS IAM, while the customer is responsible for role enforcement and policy design. And for data protection, the cloud provider is responsible for built-in encryption tools, while the customer is responsible for key management and access policies. So now let's expand on the risk a little bit. When we talk about misconfigurations, think of it as renting an apartment in a high-rise. The building provides security camera and front desk checks, but if you leave your own front door open, you are still vulnerable because that's on you. And then unencrypted data. When you have unencrypted data, you're transmitting sensitive information without encryption, and it's like sending a postcard instead of a sealed letter. And then we have excessive permissions. When users or apps have more access than they need, it's like giving the gardener keys to every room in your house, including your safe. The best practices for this would be to 1. Encrypt data both in transit and at rest. Regularly audit access policies and permissions. Use MFA and rotate credentials. Implement monitoring tools like AWS CrowdTrail or even Azure Security Center. In the visual here, we see diagram showing a secure cloud architecture layered with IAM, encryption, and monitoring tools. Please take a minute to observe that. Another real-world example here with the Tesla Kubernetes breach in 2018. The attackers leveraged a misconfigured Kubernetes cluster to run cryptocurrency mining operations on Tesla's cloud infrastructure. And the lessons learned there was poor configuration in cloud environment continues to be a major breach vector. Now, let's look at the DevSecOps, its security and the risk, and look at security in the software development itself. So, DevSecOps is about embedding security directly into the software development pipeline. It's like having a security guard stationed at every stage of a factory assembly line. So when you look at the DevSecOps workflow, it starts with continuous integration, which is called CI. This is where you merge code frequently to reduce vulnerabilities. And then within the workflow of DevSecOps is automated security testing. And you have tools like SonarQube that can catch issues as developers write code. And then you have container security, which is where you secure your Docker or Kubernetes environment. And the common risks in this area are like unchecked code dependencies. When you are reusing third-party libraries, it's like cooking with prepackaged ingredients. So if they're tainted, you know what happens? Your final product is too. And another risk under DevSecOps is no security testing in CI or CD. And it's like building a car and skipping the brake tests. That's not good. So best practices would be to make sure that you scan for unknown vulnerabilities in dependencies. Make sure that you automate security testing in your pipeline and review code for hard-coded secrets or token. Okay, so we have another visual aid here where we have the flowchart of DevSecOps lifecycle from code to deployment. So please take a minute to study that visual aid as well. Now, the real world example happened to SolarWinds supply chain attack in 2020. Threat actors, they infiltrated SolarWinds software update, infecting over 18,000 organizations globally with malicious code. And the lessons learned: maintaining a secure software supply chain is absolutely vital. Okay, next is IoT, and we'll look at the security challenges under IoT. IoT devices are convenient for everyone, including yourself, but each one also can be a gateway for attackers. They carry a lot of risk. Let's look at some common IoT security risks. Number one is default credentials. This is often not changed, allowing attackers instant access. So some of the devices that you use in your house, as soon as they're delivered and you don't change the credentials and you're using default credentials, you are leaving a room open for attackers. And no patching mechanism. So devices stay vulnerable long after flaws are discovered. And we have botnet recruitment, where devices can be hijacked and used in coordinated DDoS attacks. So think of your smart home devices like digital windows into your network. If they're not locked, someone could peek in, or worse, someone could enter without you knowing. So best practices in this area is to replace default passwords immediately the devices arrive. Then you enable firmware updates. So you can get updates. And when you get updates, you install new updates. And then separate IoT devices on different network segments. Okay. And then let's look at a real world example of Mirai botnet attack in 2016. Here we have cyber criminals that took advantage of default credentials on IoT devices to launch a massive DDoS attack. And that was setting new records in scale. Lessons learned from there is changing default device settings is critical to IoT security. And then let's look at AI and machine learning and cybersecurity risks. AI systems are only as good as their data, and attackers know it. So AI and machine learning security risks are model poisoning. This is like feeding manipulated data into training processes. And adversarial input, meaning slight image changes can trick AI into mislabeling objects. And then privacy risk. AI models can unintentionally memorize and expose sensitive data. So it's like teaching someone with fake books. If the training data is bad, the conclusion would be bad too. So best practices in this area would be to sanitize and validate training data for machine learning, and use differential privacy and robust testing, and then monitor model behavior continuously. All right, it's a real example here where AI deceived recognition. Let's see where the researchers were able to manipulate AI systems into misreading stop signs by subtly altering visual input. And the lessons learned there was that AI algorithms must be forfeited against adversarial manipulation. When we look at robotics and automation security, robotics and automated systems are reshaping industries, but they must be treated as critical endpoints. Risks in robotic security are like sensor manipulation, which is feeding false input data to change behavior, and firmware backdoors, which is malicious code inserted during manufacturing, and then weak access controls, where you have devices that accept commands from anyone. So imagine a robot designed to deliver medicine in a hospital, and if someone changes its instructions, it could go to the wrong room or deliver the wrong dose. Best practices in this area would be to apply firmware validation and signing, encrypt communications, and then set strict authentication for control access. A real-world example here would be the Stuxnet worm in 2010. This highly sophisticated worm targeted Iran's nuclear systems, marking a turning point in cyber physical warfare. And the lessons learned from there was protecting critical infrastructure demands robust cyber physical security strategies. Now, let's go to the summary and the next steps. So in summary, emerging technologies introduce exciting innovations, but they also are novel security challenges. So as they introduce exciting innovations, they also have novel security challenges. And we talked about those challenges, which are the risks that we talked about prior. Cloud, IoT, AI, and robotics all have unique attack surfaces, and each requires proactive and specialized security strategies. In real world breaches like the Teslas, the Capital Ones, or SolarWinds, they show why securing innovation is non-negotiable. So in the next module, we're going to look at security considerations in adopting emerging technologies. But I want to thank you for completing this module, and I would definitely see you in the next one. Thank you.